This video is part 2 of composition of functions. We just finished talking about how to combine functions in the previous video. In this video, we're going to learn about a composition of functions. So, when the output of one function is used as the input of another, we call the entire operation a composition of functions. For any input x and the functions f and g, this action defines a composite function. Composite function, which we write as f and then this little open circle g, such that f open circle g x. So we actually read this as f of g of x equals f of g of x. So if you look right here, we're substituting in for x an entire function. We're substituting in g. So the domain of the composite function f of g is all x such that x is in the domain of g and g of x is in the domain of f. It is important to realize that the product of functions fg is not the same as the function composition f of g of x. So f times g is not the same as f of g, because in general, f of x times g of x doesn't equal f of g of x. Alright, so let's look at and see what these look like, just in case that sounded a little bit confusing to you. Look at this example. Determine whether the composition of functions is commutative. What that means is can it be reversed? So commutative, the commutative property, just an illustration of that, 2 times 5 is the same as 5 times 2. So what they want to know is f of g of x the same as g of f of x. So that's what we're going to figure out. Okay, so we have f of x equals x squared plus 9, and we have g of x is square root of x plus 5. So let's start by finding f of g of x. So what we're going to do is we're going to substitute g of x, which is square root of x plus 5, into the x for the function f of x. So f of x was x squared plus 9. So we're going to rewrite that function, x squared plus 9, but right here in the parentheses, we're going to input the entire function of g of x, which is square root of x plus 5. So now we have the square root of x plus 5 squared. So this squared and this square root, they cancel each other out and just leave x plus 5 plus 9. And that gives us x plus 14. So f of g of x is equal to x plus 14. Okay, so now let's do the opposite. Let's do g of f of x. So that's where we're going to take g and we're going to substitute in f of x, and f of x is x squared plus 9. We're going to substitute x squared plus 9 in for the x into the function g. So the function g is the square root of x plus 5. And right here, where the x was, we're going to substitute x squared plus 9. So now, we simplify the inside, which is x squared plus 9 plus 5, and that is x squared plus 14, but that's in the square root sign. So g of f of x equals square root of x squared plus 14. So now we have f of g of x, which is x plus 14, and then we have g of f of x, which is square root of x squared plus 14. Those do not equal. Therefore, f of g of x doesn't equal g of f of x, so it's not commutative. So that illustrates two things. One, that they're not commutative. You can't necessarily reverse them. If you reverse them, they're not necessarily the same. And two, we've illustrated how you find a composite function. All right. So let's do another one. Let's just find the composite function f of g of x, where f of x is 1 over x squared plus 1, and g of x is 2x plus 4. So f o g of x. So f of g of x. So that's f of g of x, which is 2x to the 4th. And that equals f of x, which is 1 over x squared plus 1. And x squared is, the x for the x squared is this 2x to the 4th, because that's the g of x. So we're substituting g of x in for the x. And so now we just simplify. We get 1 over 2x to the 4th squared will be 4x to the 8th plus 1. And that's as far as you can go for that one. And they don't ask us to do the opposite, the g of f of x. So we're going to move on. All right, let's do another one. Now we're going to go backwards. We're going to do g of f of x. So g of f of x. So in g, we're going to substitute in f of x, which is the square root of x plus 4. And g of x is x squared. And inside the parentheses, we're going to substitute in x plus 4, because that's what f of x equals. And if you know anything about square roots, they are undone by a squared. So a square undoes a square root, and then that just leaves x plus 4. And that's as far as you can go there. All right. So now we also want to be able to interpret composite functions. So kind of make sense of it. So let's read this example. The function c of s gives the number of calories burned completing s sit-ups, and s of t gives the number of sit-ups a person can complete in t minutes. Interpret c of s of 5. So let's write down what we know. C of s is the number of calories burned for completing S sit-ups. And then they tell us that S of t is the number of sit-ups a person can complete in t minutes. So what does C of S of t mean? So what I would do is I would go from the inside out. So C and then S of t. S of t is the number of sit-ups in t minutes. And actually, for this, that's supposed to be 5, right? So in this case, that would be in 5 minutes, the number of sit-ups in 5 minutes. So, and then C of S is the calories burned. So this represents the calories burned doing the number of sit-ups a person can do in 5 minutes. Okay. So now, this one is a try it. I'm going to do this first one with you. This one right here. I'm going to do this one with you, and then I'll let you guys try the second one. So we want to find f of g of 1 using a table. So go inside out. So first we're going to figure out what is g of 1. So let's go over here. Oops. G at 1. So what you do is go to 1, and g at 1 is 3. So g at 1 is 3. So if we're finding f at g of 1, and g of 1 is 3, we're really finding f of 3. So now f of 3, so go to x equals 3, and we can see that f at 3 is actually 3. Okay, so now you guys pause the video and find g of f of 4. Okay, so now we're going to find g of f of 4. So we need to start by finding f of 4. So if we do f of 4, that is 1. So we're finding g at 1. So now g at 1, oops, g at 1 is 3. All right, great job. So now we're going to do the same thing. We're going to evaluate a composite function using a graph instead. So here we use a table. Here we're going to use a graph. And basically it's the same thing. So like for this f of g of 1, we find the point, the y-coordinate on the function g when x equals 1, and then use that number as x and find the y-coordinate for the f. You're going to do the same thing here, but if you look, we've got some steps for you. Given the composite function and graphs of its individual functions, evaluate it using the information provided by the graphs. So first we locate the given input to the inner function. So if it's f of g of x, the inner function is g. If it's g of f of x, the inner function is f. So you find the input on the x-axis of its graph and read off the output of the inner function from the y-axis of its graph. So basically you're getting the y-coordinate. And then you locate the inner function output on the x-axis of the graph of the outer function and read the output. So basically when we're doing g of f of 2, we come over here, we locate 2, and we find the point here. And then whatever that point is, that's what we substitute in for g, and locate that on the x, and then go up and find the output. So let me walk you through this. So first, we're going to find f at 2, we're going to find the inner function first. What is f of 2? So first we have to go over to f of x. This is f of x. This is g of x. So go over to f of x and find the function at 2. So go on the x-axis, go over to 2, and then here's the point right here, 2, 5. So 5 is the function f at 2. So we're finding g of 5 now. So now on the g graph, go over to 5, and we go up to the point. Now this one looks like it's halfway between, because that looks a little farther over than 5. So I think this went up 2.5. So yeah, I think this one fell about right there. So again, we went over to 2 and then up to the point right there, which was 5. Then we substituted that into the g. So the g, what is the point at 5? So we went over to 5, and then when we went up to our point, which looked like 2.5. Okay, so we're going to pause this video just to give you time to take a break, or we're going to stop the video, and we'll pick back up with evaluating composite functions using formulas. So we've evaluated using graphs and tables. Now we're going to actually evaluate using a formula. Okay, so take a break and then come back for part 3.